I'm here to teach you the basics of combinatorics. So I will first be giving you some sample questions, and then I'll teach you more, and then after that we'll go into some higher level questions. So this sample question, which I think some people would know how to figure out, where they will ask you how many different ways can you rearrange 3 different objects, which is 1 cent, the 5 cent, as well as a 10-cent coin. Now the answer to this, I will reveal it in 3, 2, 1, which is going to be 3 factorial, being 6. Now there's going to be some visual proof where I will show you, which is right here. We have 1 cent, a 5 cent, as well as a 10-cent coin. Now from here, this is our first combination, and then I'll show you the rest right now, which is where this is the second one, this is the third one, the fourth one, the fifth one, and the last one, which is the sixth one. Now when you count all these, you have 6 different ways you can rearrange those coins. Now when you look from this table, you can see that the first column, I will put the lowest value first to the highest value at the bottom. So I'll put 1 cent, then 5 cent, then 10 cent. This is because I want to count in a much simpler way without overcounting or undercounting, and just count everything one at a time. Next, when you look into combinatorics, you'll often see this symbol a lot when you try to work on a few problems. So you'll see this factorial sign, where this represents multiplying positive integers from n to 1. So that means given n factorial, you'll multiply from n, so that means n times n minus 1 times n minus 2 all the way down to 1, and that will be the product. Now for example, like 5 factorial, we have 5 times 4 times 3 times 2 times 1. So it went from 5 all the way down to 1. So in factorials, when you do some research, there will be different types of factorials. We have this double exclamation mark, as well as this hashtag. So the left one is called double factorial, and the right one, which is called the primorial. Now I won't go into details about these because I will only teach about the basics of it. But if you want to learn more about this, you can feel free to research, and yeah, feel free to explore. So here's this high level question where it's going to be quite difficult at first. So given that there exists a pair of people, how many ways do n people can be seated in a straight row? So the answer to this is going to be 2 times n minus 1 factorial. So if you want to think about why, you can think so now. You can feel free to pause it. We're going to show you the visual proof of why. So firstly, we're going to assume that the first and second are paired, which means that as you can see from this diagram, we have the first and second being paired, and the rest of the people are n minus 2 people. So we can then combine those two into 1 and 2, which is also known as combine. And then the rest of the people, which is n minus 2 people, can be brought down from here, and then after that we can combine all those again into n minus 1 people. So from here we can find the number of ways to rearrange n minus 1 people, which is n minus 1 factorial, a number of ways to rearrange 1 and 2, which is only 2 factorial, and then the number of ways to rearrange according to the question, which is 2 factorial times n minus 1 factorial, which means the answer is 2 times n minus 1 factorial. Alright, now we have this extra question. Now feel free to give it a try, because this is going to be a higher level, much more of a step from a previous question, if you want to try and get this correct. Now, given that there exist n pairs of people, how many ways do n people can be seated in a straight row? Now, I'll just give you an answer, and maybe you can feel free to pause it as much as you want. But I'll give you the answer in 3, 2, 1, which is going to be 2 to the power n times n minus 1 factorial. Now, I won't show you how I would get it because this is a much more generalized version, where the previous exercise we did one pair of people. Now in this exercise we did n pairs of people, which means that from there you can actually solve it, which is quite nice. But I'll just leave it to it, and thank you very much for watching.